Okay, good morning. How's everyone doing? Good, good. My name is Corey Sanders. I'm going to talk to you a little bit about infrastructure as a service today and how it works. I'm going to be spending time talking about both why we did it, a little bit of how you may want to use it, and a little bit underneath, and give you some details on how it's working sort of in the background. One quick sort of survey. How many people saw Scott's kind of overview of Windows Azure? Okay, good bit. How many saw Mark's talk on infrastructure as a service on virtual machines? Okay, kind of roughly the same people. Okay, so I'll probably try and give a little bit of some overview as well, just make sure people understand sort of what we're talking about. This does dabble between 200 and 300 level, just so everyone knows. If you find that it's too deep, you can throw something at me or leave or something. But hopefully we bounce back and forth a little bit, and I do go deep enough that you can actually use it, but I also give you enough of the high level so that you sort of understand what it's all about. So just to get started, this previous, actually 2 weeks ago, Thursday, 6/7, we ended up launching infrastructure as a service, which included support for a SQL Server in Windows Azure. It included support for Windows Server Active Directory, which included cross-premise connectivity as well. I will touch upon that, but I won't go into too much detail on that. It also included support for SharePoint Server 2010, and I'll also touch on this. It furthermore included this guy. We added support for Linux as part of this launch. We're very excited about this. We're excited about the openness to the platform. We're excited about the possibilities that it will make for people to deploy applications of any kind that they may want. It's not something I'm going to focus on today. It is something we do have a specific Linux-focused session on Friday that you can go attend, and there's also some of our partners will be there as well to talk a lot about sort of what we've done with Linux. I won't focus on it too much today. So today's talk, what I am going to focus on is, first I'm going to start with why are we doing this? For a lot of you, you may sort of be wondering why we haven't done it until now, so that may be a quick section, but I'll talk about it. I'll talk about the applications that we're focusing on and why. I'll explain what persistence really means, what it means to us, and how disks work, sort of what's going on in the background, what you're going to see through the virtual machine and why. Then I'll spend a little time talking about how do I use it. I'll talk about dev test as kind of one of the best examples for how to use this. And then I'll go back to the applications and go sort of a level deeper on those applications. So I have a bunch of demos. I do have a few things that I'll show you. And so from there, let's kind of just charge forward. So why infrastructure as a service? So if you sort of look at this changing cloud continuum, and you look at this picture, and it's a very marketing picture, so it's one of the last ones, and then I'll move on to sort of the more engineering and more fun stuff. You sort of look at the x-axis here, and you've got control versus abstraction, right? And as you move all the way to the left, you've got a lot of control, and to the right, obviously, is more of abstraction. And with that axis comes cost efficiency, right? As you move to software as a service and platform as a service, it becomes a lot more cost effective, right? It's a lot cheaper to run, but you have a lot less control. And this is sort of that tough trade-off that you get between platform as a service versus infrastructure as a service. And so when you look at the platform before this launch, it's actually a couple weeks ago, where we had SQL Azure and Windows Azure, it really was a platform as a service offering. It's very focused on that. Obviously, Microsoft Software as a Service is Office 365, which you may or may not be familiar with. And of course, our virtualized data center offering, System Center and Windows Server with Hyper-V is sort of the Microsoft offering. There are also competitors out there. So for infrastructure as a service with Windows Azure, the real goal here was to supply existing application support. When you think of that control versus abstraction, a lot of existing applications that even Microsoft has and some of our partners and competitors have require quite a bit more control. But it also means that you end up having a little bit more of that management requirement, right? So that cost efficiency goes down. You have to go back and manage these systems just like you manage them on premises, which is both good and bad. But that management goes hand in hand with that supply for existing application support. And that's kind of the trade-off that we have here. So when I say existing application support, the way we really thought about infrastructure as a service in this last year that I've been working on it is really this sort of definition. If it requires developer involvement to deploy an existing application, it's not infrastructure as a service. And we really sort of tried to live up to that. It took us some time. Obviously, the team was really platform as a service focused until about a year and a half ago, or when we really started thinking about, hey, what should we do here? And so when we started testing, actually, one of the first partners that we tested with was Active Directory. and they started deploying in Windows Azure, and they launched up their Active Directory, and they said, hey, it doesn't work at all right now. And this was about 6-7 months ago. It doesn't work. And so we looked at it. Active Directory actually has a requirement for fragmented UDP, which we had no support for. We had never even thought about, right? I didn't even know what fragmented UDP was before they said it didn't work. And so we looked at it, and actually a few of the developers in my team, embarrassingly, a few of the developers in my team came back and said, well, can we just tell them to change their application? And of course, no. It's Active Directory. It's Windows. We can't just go back and tell the Windows team, change your application to work in Windows Azure. So this was kind of the rude awakening that we had in the team. Luckily, it happened a while ago, so we feel a lot better now. But it was one of those things that when we approach the problem, it becomes more of what can Windows Azure do to make the app work instead of what can the app do to work in Windows Azure. And that is kind of the big shift between platform as a service and infrastructure as a service for us. So when I think about what I built, while I love infrastructure as a service, I've been working on it for a long time, I'm really passionate about it, it's my baby. Really what I built was a road. Right? It wasn't really anything fancy, it was a road. It was a way for people to drive someplace. And when I think of infrastructure as a service, it really is sort of this ramp to be able to get onto the cloud superhighway. It makes it possible to drive there. And so my pretty animation of a car, the application is actually the car. It took a long time to build. You'd be surprised how long it took to build that. I love PowerPoint. Okay, when you really think about it, the car is the application. This happens to be a very fancy car. It may not be a fancy car. But the whole point is that we built a road, and you guys are supplying the application. But the application, the car, is what really matters. It's what is really interesting. The road, of course, has to be there. It has to work. It has to be. There can't be a lot of holes in it, right? And so it's kind of my analogy that I've come up with for what I've worked on. So given that, there's a few ways to actually, and before we sort of dig into those applications, there's a few ways to actually use the platform. One is, of course, the management portal. I'll spend some time there today. One is scripting. I'm also going to spend some time on this today. There hasn't probably been a lot of coverage on scripting yet, so a lot of my demos actually go into the scripting, and I'll show you what that all means. In fact, I'll show in just a minute what that means. And all of this is built on REST APIs. So in the back end, we have REST APIs that have all of the functionality that both the portal and the scripting technology uses. It's, in fact, completely the same technology that's available to you. So you could effectively go completely write this management portal yourself if you wanted to, which we're really passionate about. In previous versions of Windows Azure, we had sort of our internal portal using APIs that weren't exposed externally. We've moved away from that with the goal of saying that this is really just an implementation of what you may want to do on top of the REST APIs. And so you look at scripting, you can develop your own, and of course you can use the UI. So let me just quickly sort of start with just a fast demo here, just to sort of show you sort of what I'm talking about. So obviously this is the portal, but my first demo I'm going to do is actually a scripting demo. And if you're familiar with PowerShell and with Windows Azure and PowerShell, the first step is really getting your publishing profile and settings down. And it used to be pretty complicated to sort of connect for the first time with PowerShell. It's very easy now. There's just actually just a link you sign in, and it's called Publish Profile. Let me zoom in here and show you just quickly what I'm looking at. Download Publish Profile, and with this, you're able to immediately download profile settings. Oh, that's terrible. You can download, sorry about this. I left it idle too long. Maybe I've been fired. Okay. So I actually happen to have done it ahead of time, but so this will go to this page. It'll allow me to download these published settings here. I'm actually going to cancel because I already have them. And then here what I have is this PowerShell ISE. And so you'll see here I've imported obviously the management, the PowerShell management for Windows Azure. And then here's the import published settings file. And so I've downloaded this already. So I've just got it on my local machine, and that's all I need to do to be able to connect and use my account. And then from here, let me actually skip to the fast VM creation, which is what I'm showing you. Again, you see the published settings here. And from here, what I've done here is just to show you this fast demo for scripting purposes. I picked my image, which here is listed as the SQL Server image. There's a PowerShell command to give you the full list of images. So it's the SQL Server image from eval image, and I've selected the location that I want this to go to in my storage account. And then from there, it's just a new VM config. I can pick that it's Windows, I pick my password, I pick my location that I want to deploy, and the size, and then I can just launch it. And so you can see it's picking up those settings, it's creating that cloud service background. And actually what I can show you here while that's going. And so here's the VHD that I just created from that SQL Server image, and now it's booting. So I'll come back and talk a little bit more about what that all means, but let me switch back. So I mentioned SQL in that demo. When we talk about, again, infrastructure as a service, it's really about the apps versus the infrastructure. And so the three big apps that we really focused on were SQL Server, Active Directory, and SharePoint. There's a couple reasons why we focused on these three. One is because they're actually the most common and most interesting applications for running in Windows Azure. We got a lot of requests for these specific three applications. They're also somewhat representative of sort of an application class. So SQL Server is a good example of a database, a very heavy disk usage application. In fact, the SQL Server team defined our exit criteria for performance on the disk. They said it has to be here or we can't ship with you, which was good for the platform but very painful to work with them on. Obviously, Active Directory is a very network-intense component. It uses a lot of specific LAN-type networking expectations like fragmented UDP. And so they really helped us get through our networking expectations and requirements. And of course, SharePoint is sort of this multi-tier, massive application with a load-balanced front end. And so they defined a lot of our expectations on what the load balancer needs to do and how these components need to all come together. Because SharePoint ends up actually having a dependency on SQL Server and Active Directory. And so the joke that we made in the team frequently was, once SharePoint works, we ship. And that was actually effectively what we did. And so these are the three applications we look at. When we look at versions, we sort of picked at least the most recent version. Sometimes we went back previous versions. The SQL Server team was very passionate about going back a few versions. We will obviously move forward in versions as these guys come out. But this is sort of where we stand today. And when you actually look at why we picked versions, sort of why did we limit it to specific versions, there were a few reasons. We're really passionate about making sure that Microsoft applications and Windows Azure work really well together. Right? We really wanted to make this just the best place to run these applications. So working well together means they better be better. It's very hard to say that 3 times fast. It's tough. So we really focused on making sure that support was there, that testing was there, that we felt really, really good about these things working. Right? So the support teams from SharePoint, the support teams from SQL Server, and of course the support teams from Windows all were involved in our sign-off. They were there, they were watching, they were testing with us. And so we feel really good about these applications working really well. Does it mean we block other versions or block other applications? Absolutely not. Right? We actually don't even know what you're running, actually. But it means that these three we know work really well in those specific versions, and that's been sort of our passion. So from the gallery, and I'll show you some pictures of this, we actually have some images that are available just to launch. Windows Server 2008 R2, SQL Server 2012 eval, and Windows Server 2012 RC. This is specifically during the preview period. We expect this to continue to grow over time. And then, of course, on the Linux side, we have OpenSUSE, CentOS, Ubuntu, and, of course, SUSE Linux Enterprise Server. And so I'll show you a few of the Windows sides today, and, of course, Linux will be later this week. So it would be remiss of me to talk about the things that work really well without mentioning at least once the things that we know don't work really well. And this is really intended to make sure that you don't go and try these things and get frustrated, right? They don't work. Hyper-V definitely doesn't work. Hyper-V on top of Hyper-V doesn't work. It's not it actually won't even install. DHCP and NLB. So DHCP, obviously setting up a DHCP server. NLB is a network load balancer that's built into Windows. Neither of these work because they require broadcast. Our network doesn't support broadcast or multicast. It's for security reasons. It is something that we are looking at in the future, but right now there's no support for that. So this actually extends out to just your broader application base. If you have a broadcast multicast scenario, it won't work. Failover clustering doesn't work, and this is actually another networking specific problem. It is the IP address for failover clustering has to actually move with that cluster. It doesn't move in Windows Azure, and thus this will not work. And then, of course, BitLocker. We have no TPM chips on these virtual boxes, so this doesn't work as well. So I felt it necessary to talk about the sort of negatives first, and then the rest will be all the positive stuff. Okay. So what about licensing? This is kind of an interesting and a little bit bizarre sort of approach here. The Windows license is actually per hour in the cloud. So your Windows license doesn't move with you. So you're running Windows in the cloud is supplying the license, you keep that Windows license on premises. It doesn't move. Application license, so SharePoint, SQL, today this is only supplied by application mobility. Right? So if you're an SA customer or SA partner, you bring your own, and that application license does move with you. Right? And this is all the server application licenses. And then external licenses, this is based on that vendor or that product. Right? We are constantly working with vendors and products to extend and expand this licensing story. But as of right now, it's really based on each one of those vendors and what their product is. Did I see a hand go up? No. Yes? No. We'll get it later. Cool. All right. Licensing can be sticky, so we can talk also offline as well if you want to talk more about licensing. There's a lot of interesting points to this as well. Okay. So that's kind of the details of the application and the licensing story there. And what is persistence? Right? We talk a lot about this. We say, okay, well, platform as a service is stateless. Infrastructure as a service is persistent. What does that actually even mean? So kind of a simple approach here to what that means is, it means that the VM is actually booting from a drive that even if that hardware dies, the drive will stick around. So to us, that means we have your disks, your VHDs, that these guys are booting from are actually in Windows Azure Storage. And I don't mean that they're backed up to Windows Azure Storage. You're actually booting from Windows Azure Storage. Right? And so these VMs are booting directly from it. Your data disks are directly from it, which means a few things that are actually really cool. First of all, you get triplicate copies. Right? So you have high durability. So if one of those disks dies in Windows Azure Storage, you actually don't even know. You won't see it. There'll be absolutely no disruption if one of the disks die in storage. We just replace it for you automatically, fix it, have that third copy, and you start reading from the other copies in the meantime. And we all handle that behind the scenes. So it means that storage concept, the disk concepts, that goes away. It means if you choose, you can actually have geo-replicated for your data. So this means at least 400 miles away, you can say in that same geo region, I want that data to be geo-replicated. This means your data disk, it means your OS disk. Right? So all of those things now are replicated another time in another region. It also means that if that physical machine that you're running that virtual machine on, the one that we're managing and hosting for you, that if this guy dies, we actually will automatically detect and recover and reboot you on another physical box. So if that physical box goes down for whatever reason, the hardware just doesn't boot back up or whatever it may be, your virtual machine is stuck on that box, we will detect it and move you. Right? This, you will see a little bit of disruption. It will look like a hard reboot, but we will reboot you and recover you on another physical machine. Because your disks are stored in Windows Azure Storage, nothing is lost. Right? And that's kind of really what persistent means to us. It means both physical failures, you'll be able to recover from it, and all those writes are going off to another location. So one of the big things and one of the big choices that we made in our infrastructure as a service offering is to use just VHDs in your storage account. Right? You saw my first demo where I spun that up, and I picked one of the gallery images. I said, I want this SQL Server eval image. And then it popped up as a VHD in my account. That's just a standard fixed VHD that's sitting in my storage account that I can do with what I will. So this means there's a lot of power for you to move these VHDs around. You can take one from your data center and put it up into the cloud. You can also take one from the cloud and bring it back down to your data center. Right? Assuming the licensing is all aligned and everything is set up so that you can actually run these things into two locations, right? These VHDs just move. They're just formats that you know of that can be converted around, and it's just an open format. Similarly, going from Windows Azure to another service provider is also very easy. Right? And the goal was to be able to say that, look, we're trying to create a service that allows you to deploy your application, right? Which means that it may be better at some times to be in a different location, whether it be on-premise or in another service provider. As long as you're able to move between them, we want that to be very, very easy and possible. And so that's why we chose this approach. And so, again, you can move these VHDs between Windows Azure and other service providers as well. Great. So let me spend just a couple minutes on how provisioning works, and then I'm going to spend some time on some demos. So now that I mentioned sort of that VHD format in the back end, there are two important concepts to point out here. We have this concept of a disk, and we have this concept of an image. And these are kind of copying the terminology that Windows Setup uses. When we started this, we were actually only doing Windows. We added Linux later, so we chose the Windows terminology. And so the image concept is really intended to be sysprepped, generalized, and be able to spin up many different instantiations of that same box. Right? And so when you look at this, it's a Windows box, it's sysprepped. It means we can provision and supply information to it, like the administrative password, like Active Directory settings. Right? How many people are familiar with sysprep, so I know how much detail to go into? Okay, so a good amount. Sysprep ends up being the way that Windows actually sets up your Windows box with all this configuration. We just leverage that. And so it means that any sort of VHD that you've got on-premise or in the cloud that's sysprepped, we can provision for you because we just use that technology. Now, disks are that instantiation. Right? So disks are actually an already booted, already set up Windows VHD, or Linux VHD, of course. This means that these can just be booted. They can be turned on, but they'll then go from there. Right? You're not actually provisioning them with your administrative password and so on. They just kind of boot up and run. Right? And both of these are supported. One is one that we can provision, and one is one that you're just booting. And I'll kind of show that here with some demos. So the provisioning story, when I say an image, what this means and what I just showed you when I started that SQL Server box is you take one of our stock images, let's say, and the first thing that happens is you say, I want to add this server. And you saw that PowerShell script. I can show it to you again. You supply things like the host name. You supply things like the password. You can also do it through the portal as well, obviously. And I'll walk through that here in a minute. With that, it goes into Windows Azure. We actually turn that into an ISO. So we turn that into a DVD, and we put an unattend file on it. Again, for the people who raise sysprep, unattend is, well, either your friend or your enemy, but you're familiar with it. And so we drop an unattend file that we generate based on the information you supply, which now means Windows can read this. So we copy that VHD, which is sysprepped, into your storage account. So that's what you saw when I showed you. It just showed up in my storage account. We lock it. And so I'll explain the lease story later. This is really for my own protection. It's not anything involving the platform, making sure you're not doing something wrong with it. It's to make sure I don't accidentally delete it while I'm booting from it. And then we create a virtual machine. We have a local drive that's intended for the paging file only. And then we have the OS disk and the data disk, and we attach them. And as I mentioned before, these are literally running from Windows Azure Storage. And then to provision, we connect this ISO, and we boot. And Windows knows to look for this ISO, finds the unattend file, boots it, and sets up the box. Right? And so that's effectively how provisioning works in the platform, in the background. And let me show you what you actually see here. Oops, there we go. Okay. So this is the portal. It's a very, very pretty HTML, fantastic. I use it on my phone, actually, my Windows phone. Just kidding, just kidding. Okay. All right, let me go here. New virtual machine, and let me show you sort of what I mean when I say provision. So, like I said, platform images. I can pick any of these platform images that I may want to use. And from here, I'm able to select a lot of different options. So let me go here and do Windows Server 2012 RC and hit Next. Now you see here, this is my configuration. This is where I can put in my virtual machine name. This is where I can put in my password. This is going directly into that unattend file I showed you. This is what's being used to provision. Right? And so here I'm going to pick, let's say, demo VM. Okay, password. Okay, I can pick the size that I want, so I'm going to go with small right now. But the other options, obviously medium, large, extra large. Okay, and at this point, because this guy's just a single VM that I want to go build, and I want to show you how it works, I'm just going to do standalone. I'll mention connect a little bit later. Okay, put this into the storage account that I want this to go to. It's going to be West US. Okay, and I'll mention that later as well. And away I go. And so with that, I've now created and provisioned this virtual machine with those settings that I wanted. Now in the background, we're taking that information and, of course, turning it into that ISO, unattend, and doing all that rest of the work for you. And so that's kind of what's happening under the scenes. And so similar to what's possible there for the gallery supplied image, you can also do this with a supplied image that you have, right? And so if you have a sysprepped image just sitting around, or you want to do this in the cloud, there's a few things that you can do. The first one is this capture process, which, again, I'm not going to go into too much detail, but it really is a glorified copy, right? And so if you're running in the cloud, let's say I finish with this image and I've installed X number of applications and I feel good about it, and then I want to sysprep it again so I can re-provision hundreds, thousands of them, whatever I may want to do, on-premise or in the cloud. What I can do is run through this capture process, which means I'll go in, I'll sysprep it, and then I'll shut it down, just like I would on-premises. And then I can copy this. And the capture process really just takes that VHD and copies it as an image. And so now what this means is the next time I go around, the image that I'm starting with isn't one from our gallery. It's one from your account, right? And so then you've created, either you've uploaded or you've created one using this capture process. You can now run through that same process I just showed you, because we can provision it with ad server, with the password, with the username, and we can copy it in, and the same process applies. Same ISO, we copy the image, and away we go. Let's go through these animations real fast. Okay. So let me just quickly show you exactly that same thing. Okay. So what I have here is I have a couple things. One, I have an image that I've uploaded, which is just a Windows Server image that I brought from on-premises into the cloud using CS Upload, which is a tool that I won't go into. Actually, Vijay's got a session tomorrow to talk about that. And then there's, of course, this captured image that I happen to have been running, and I went through the capture process. And so both of these are just images in my account. If I actually show you here in my storage account over here, this one's actually the captured image. We supply it with this bizarre-looking name, something that we have to fix, actually. But it is a random-generated name. And then, of course, there's one that I uploaded, and that's the name that I picked. And so these two images are available for me. And so what you'll see here is same sort of process. I can go in, virtual machine from gallery, my images this time. And so you'll see here I have both the captured image and, of course, the uploaded image there. And so with this, I can pick which one of these. Let's say I pick the captured image, and I can walk through, and you'll see I have the exact same capabilities to supply the virtual machine name, the password, etc. It will provision that same thing for me. Okay. So let me actually show you sort of a little bit of what that looked like. So in this case, let me take this guy. And again, because these are just VHDs running in my storage account, I'm going to go ahead and copy him, go into my backup folder, and paste. Because it's Windows Azure Storage, these are shadow copies, so they're instantaneous. So you see that was a 32 gig VHD that I just copied, and it's now ready for me to use. And so here what I'm going to do is do a copied image. Okay, let's move this guy back into this main section. And so what I've done here now, and this tool, by the way, is Cloud Explorer. It's a third-party tool. It allows me to sort of navigate around my storage account in sort of a very UI-friendly way. What I've done is I've taken this image that I've created in the past and I've copied it. Now you can imagine using this if you've created an image that you really like and your coworker wants to use it. This allows you to sort of copy between each other, right? You can say, hey, use this. This has all the stuff installed that we need installed. And so I have it here, and I just made a copy into my own storage account. And I can go in and say, great, let me go in and now actually create this as an image in my account. So I'll say copied image. Okay, and there you see in my storage account I have that file that I just copied. And so he's sitting there. I've got, let me zoom in here just to make sure you can see it. So there's copied image. It's in my storage account. Hit open. And now I'm going to say, yes, this has been sysprepped. This is sort of my warning. And I'll hit OK. And so this is really just adding a reference to this so that I can now use it as part of my account. Right? And so as that comes in, what I'm actually going to do to provision this guy is use PowerShell. So let me come back here and show you sort of what I'm going to do with PowerShell. So similar settings to import the publish settings. But now you'll see that my image name is copied image. It's not that full, long platform image name, right? It doesn't have SQL eval in it. It's this copied image. This is the one that I just added in. And I'm going to move it to this location called copied disk. And this is just a storage account that I happen to own. And so walking through some of the provisioning details, the name of the VM was going to be copied image create, size small, same image name, password, etc. And of course the service name will be Corey copied image. This is all going to be in the West US. So let me just double check that's done. Very good. It's there. So now I should be able to use it. So let me hit play on this and just watch this come in. So great question. So if it wasn't sysprepped, and in fact I'll show a quick demo of that here in a minute, if it's not sysprepped, you don't want to bring it in as a Windows image. You want to bring it in as just a disk, right? And I'll show that sort of walkthrough. If you bring it in as an image and it's not sysprepped, we expect a response from a little agent that we have running inside our sysprep commands to tell us when we're done, right? And so if we don't ever hear that, we say, oh, this timed out. It didn't look like it worked. What's funny is that in the background, we're actually just booting it. So your image will still work. Even in that case, it'll just show a failure, right? Because we're just booting it up. So I'll walk you through actually what that looks like. Great question, though. Okay, so in this case, you see I've got, let's see here. Oh, great. So it succeeded. It's now, go ahead, it's provisioning this. So let me just refresh this. And there you see copied disk. So what just happened, I took that copied image. It's read-only because it's intended to be an image. And so we copied it, just like I showed you, added those provisioning details, and this is now booting. And so actually you can see here, let me refresh. And you can see every couple seconds this is actually getting updated as we speak. Okay. And I can go back to the portal. Actually, let me just close this. I can go back to the portal and I can show you now. Let's see here. Great. And there's the copied image create. You saw that's the name I selected. And it should, as soon as the status comes in here, it should show that it's provisioning. Very good. Okay. So this is sort of the question that was just asked. What will work on upload? Right, what are you allowed to use? Well, so obviously images work really well. And so if you've sysprepped these guys, if they're VHDs that you've created on Hyper-V, or you've converted, right? You don't have to create them on Hyper-V, but they've been sysprepped. They work really, really well. Sysprep actually does a lot of great things to make sure that these images move cleanly and actually successfully. But there are a lot of situations where sysprep can't be used. A lot of cases where you don't want to use sysprep. And these are just the disk concepts. These work pretty well. You see the equal sign is smaller. I had a hard time figuring out how to say pretty well. The key thing here is that there are things that will not work in this environment. Right? So things like if you have multiple NICs, right? Those don't come up because we don't support multiple NICs. Sysprep kind of cleans that up. So there's some things that don't work as part of just bringing a disk. If you haven't sysprepped it, it may or may not work. Probably my recommendation is try it on premises first. Try moving from one physical box to another physical box. If that works, it probably works in the cloud. The thing is that if you're not sysprepping it, don't bring it in as an image, because like I just mentioned, we'll try and provision it. We'll try and run through sysprep, but if it's not sysprepped, it just sits there, right? So the disk concept is really just we're booting it. You're just taking a VHD and we're going to boot it in the cloud, right? We're not going to try and do anything fancy. And so let me show you sort of what that looks like, actually. Oh, yeah, quickly, what should you avoid? So I kind of just mentioned these. Because we're using sysprep, there's sort of three big things that you should avoid. One is that you do want to make sure that you generalize and sysprep these images. Right? If they're not generalized and sysprepped, they won't actually go through our provisioning pipeline. And this is only for the image concept. Do not put an unattended file on the disk. Do not put it on that image, actually. Because it will probably trump the one that we supply on an ISO. Right? If you know the sysprep rules, all that. If you're familiar with Windows Azure today, how many people are familiar with Windows Azure and the VM role today? Okay, unfamiliarize yourself with it. You do not want to put that agent from the VM role on these guys. If you're not familiar with it, forget I mentioned anything. And the final point here, and the part that actually the reason why we're using sysprep for this, there's no agent required. Right? So this is what we're really sort of passionate about in the team. We wanted to make it really, really easy to take stuff that you already know and just use it. Right? So you do not need to put an agent. There's no Windows Azure agent that you need to install anywhere. You can just take a sysprepped image and it'll work. Right? Because we end up doing the rest using sysprep. So it's a very important point. It's very exciting for us. It may not be as exciting for you. But anyway, that's one of the important things. So let me just show you booting a disk now, as per the question here. So let me go back here to this account. And so let me just refresh this. Great. So I have a couple of Windows Server 2012 machines running. Okay, and these guys are running right now. I'm writing to them. I'll actually show them in a little bit. If I go ahead and copy this, I sort of like it the way it is, and then paste it in this backup directory. And let me rename it now. So obviously this guy's running, which means I did not sysprep it. And in fact, because I copied it while it was running, it wasn't a clean shutdown. So I probably wouldn't recommend doing this on a regular basis, but let me go ahead and copy this back. Okay, so I'll go into my account, and for this guy that has not been sysprepped, but I still want to just boot him. Right? I just want to go ahead and boot him. I made a backup, or I liked him and I wanted to make 6 of these guys. I can go in now and add him directly as a disk, and you see I clicked on the disk section up here instead of the image. That's a terrible circle. Instead of the image section, which is here. I write code better than I draw circles, I swear. Okay. Let me go ahead and add this disk. Okay, so here I'll say copy disk. Go into my storage account, which I just copied this guy in. Okay, there he is. He's sitting there, ready to go. This guy does contain an operating system, so this will allow me to boot him. Actually, let me just call him copy disk 2, just in case. Okay, and so as this guy comes in, this is, again, just a reference. Right? The actual disk is in Windows Azure Storage. This is just making sure you can use it in your account and making sure someone else from another account isn't trying to use it. And so that's an important sort of, we add this reference to it in your account. And so as this guy comes in, it should be fairly quick. What we're going to walk through then is sort of just showing you how to boot from him. And again, this is not going through the provisioning pipeline. It's just booting. So let's see here. Okay. Should just take a moment. And so while that's coming in here, we can see that that copied image is still provisioning, but the original one that I started, the demo VM that I started at the very beginning is now done. I can log into this guy, and I'll show you here in a minute what that looks like too. Okay, let me just... Okay, great. So there he is, copy disk 2. He's ready to use. So again, I go through this same process that I showed you before, create a virtual machine from gallery, but this time I'm clicking on my disks. Just in case. Let me try this again. There we go. Look at that. All right. My disks, and here you see I've got copied disk 2. This is the guy I just copied and brought in here. Move in. And now you'll see I can't pick the password. This password's got to be set. RDP's already got to be turned on. Right? Everything's got to be set up the way I would have wanted it set up. The only thing I'm doing is picking a name so it shows in my list correctly. Again, I can pick the size, though. Pick the right location here. Oh, the other important point, I can't pick my storage account here. Because this is coming from a disk that's an image, that's already in my storage account, it's got to be the same one. Right? When the other one, it could go into any storage account because it's coming from our gallery. Okay? And then this will just boot. So it will actually be a lot faster than the provisioning process because it's simply just giving it power. Okay, great. Okay, so that's kind of the difference between disks and images. Was that relatively clear? Yes, go ahead. Great question. So the question was, what are you going to do about the DNS name? So the DNS name is supplied as part of DHCP, as part of boot, right? So I'm sorry, the DNS server is supplied as part of boot, right? So we'll actually take whatever name that you've got on your virtual machine and using DHCP, be able to get that machine name and be able to reference it from other machines in your service. Did I answer your question? What's that? Sorry, I couldn't hear you. That's correct. Give me actually just a few slides from now, and I'll talk a little bit more detail on that. That's a great question. For others, the disks, images, sort of? Good? Okay. I'll move on. I don't have more slides on it, so I hope it's good. Okay, how do disks work? So let me just talk a little bit more on storage and our underlying technology there, just to show you a little bit about what this actually means and why we're excited about using Windows Azure Storage. So I draw a really big picture. Storage is really big. I didn't even have room on the slide to show all of storage. So when you're running a VM, like I showed you before, there's a few disks at play here, right? There's one that's actually a disk that's on the host OS, right? And this is intended just for temporary storage. It will typically be on Windows Drive D, and it's intended really for the paging file, and maybe if you want some scratch space. Don't put anything on here that you want to save. I'm sorry, that's this one, the temporary storage disk. That's Drive D. Then your OS disk and data disks are actually in Windows Azure Storage. And so what I show here is Windows Azure Storage is sort of a shared resource, right? And so it ends up being lots and lots of disks all over Windows Azure Storage that lots and lots of people are using. But what's really great about Windows Azure Storage is that it figures out when people are using things, and it will automatically load balance things when needed, right? And so when disks are hot, when VMs are hot, when machines are hot in storage, it detects this and moves things. It's actually one of the more interesting aspects of the platform. The more you use your disk, the better the performance will get. And so as you use your disk more and more and more, we'll detect this usage and we'll start load balancing you to make sure that we can do that. And we'll even load balance you splitting up your actual VHD, right, and find the right place to put you and right way to read from you. So as you continue to use it, you'll see more I/O per second. You'll see better latency over time. Great. And of course, it's just big. There's lots and lots of disks for us to play with, for us to move around with, and that's the Windows Azure Storage system is so powerful. Great. So when I say sort of the disk layout, and I mentioned Drive C, Drive D, and of course your data disks, if you look at Windows Server 2012 and the setup, Drive C, this is where your OS disk is. This is persistent. It will be a SATA disk. It is default cache read-write. And I'm just going to mention this quickly. I don't go into too much detail on the cache. The main point is that on the OS disk, we have the cache on, and it's a cache that's sitting within the host. The only reason why we do this is to speed up boot. So boot gets a lot faster because of this, right? It's a very small write cache, but it does exist. And you can really sort of think of this as a cache sort of sitting on your SCSI controller, right? So it's sitting there, and then it writes out to Windows Azure Storage. You don't even see it. And this ends up being your C drive. We then also have this resource, this temporary storage location, which is not persistent. It's also SATA, and it's always Drive D on Windows because it's SATA. And it's local. Don't put things on this unless you're comfortable with them being wiped out randomly. Because if the machine dies, this goes with it. And this is why the only thing we put on here is the paging file. And this will be Drive D. And then any data disks that come in, these actually come in as SCSI. And the reason why we chose SCSI is because they're hot. So you can hot add, and hot remove them without a reboot, which is very powerful for you to be able to play around with these disks and move them around without your Windows machine being rebooted. We default to no cache here. The main reason for this is to make sure that if you're putting sort of a database, your Active Directory database, all of that should be on this drive because it's a write-through capability. And so any writes that happen go directly to Windows Azure Storage. There's no loss of data. Everything that you really want to keep up to date, you put on this drive, on any data disk that you may add. You can add up to 16 on an extra large, so you can really make this a lot of data disks here. And of course, the drive letter will be defined by you. You can pick what drive letter as it comes in. And that, I picked F here. So same thing with Server 2008 R2, just to quickly sort of walk you through what this looks like. Right? You can go through similar concept, Drive D, and then of course Drive F. And so when you're adding a blank disk, and I'll show this demo, it comes in, it will be auto-onlined, but it comes in as an unformatted disk. It's just a VHD. The main reason it's unformatted is because we want to be able to support both Windows and Linux. And so it comes in, and you can format this. And so you'll see it pop. You'll see a drive show up in your disk settings inside Windows. You can obviously walk through just the initialize, and then the format, and this is where you pick that drive letter. Once you've done this the first time, because we auto-online them, from then on, they just show up, right? And they show up with that drive letter that you selected. Great. Then you can use, copy, download, whatever you want to do. And data disks, again, being VHDs, is really powerful, right? Because you can back up just by copying and pasting into your storage account, and you've instantly made a backup, right? And so it allows you to do a lot of really, really, really powerful things. So let me show you some of this powerful fun here. Okay. So let me go back to my virtual machines. Okay. So this Windows SQL VM, this is the guy I started here right at the very beginning. Let me go in and just show you how easy it is to attach an empty disk. Okay. So I go in, I can attach an empty disk. Here I've got the storage location that I want to select. Pick the file name here. Pick the size. Let's just go 500. Okay. And so that's simple. I've now attached a 500 gigabyte database disk to this. I can again go in and format it. So let me show you one that I've already actually got prepared ahead of time. So here I can say attach disk, and you can see I have a few disks here that are available. Some of these are OS disks, right? So some of them are OS disks that I can attach and sort of look at the OS drive from a mounted location. Some of them are just data disks, so I'll go large data disk, hit OK. And let me go ahead and connect to this guy. And while that's connecting, one thing that I didn't show earlier that's worth showing here, similar to what you can do with websites, if you've seen some of that, you can also track CPU usage, data in, data out, and disk read throughput on the portal here using this monitoring information. Right, so you can track all of your information. You can pick which one you want to look at. So if I want to remove this guy, I don't have to see the disk throughput, or I can see it, whichever I want to choose to do. And while this is connecting, likewise, you can actually also do this using PowerShell. So just what I showed you before. So again, you can include those published settings. You can pick your VM that you want to add it to. You can pick the disk name that you want to add. And then, of course, you're just adding it straight away. Again, similar sort of. Through PowerShell, you can actually select the LUN that you want to add it to as well. So this lets you pick which LUN on that virtual machine to put that data disk on. Okay, great. So I'm connected now. Let me pull up. Hopefully, I beat the drive. Oh, I didn't. Connection was too slow. So there's the drive. You can see this is a large disk file. Okay, TechEd the best. That's true. Okay, and so let me go ahead here and show you, since I was too slow to connect and the disk was added faster than I was able to get to it. Let me actually go here and show you now on this machine. Oh, sorry. Let me go here. Just go back here. Okay, well, I'll come back to that actually later and show you sort of the detach process. But from here you can see this disk got added. Let me actually go into the SQL machine and show you what that looked like. That connection is going to take a while too. Okay. Well, let me show you here. For the Windows Server 2012 machine, I can now hit Detach Disk and see I've got my large data disk there. I can hit OK, and I'll go ahead and detach that guy while I'm waiting for that to happen. I can connect to the SQL box. And so here's Here's, of course, my SQL Server 2012 machine with the big data disk there connecting over here. Network works better today than it did yesterday. Yesterday I was getting nervous about my demos. Okay. So as I'm connecting over there, you can see here, this is, of course, the OS disk. And the temporary storage, you can see there's nothing on here. This is where, of course, the paging file will go. And so typically it takes just a minute or so to detach. There we go. And so you see now that disk is gone, I can go attach it to somewhere else. And so it seemed a lot faster to attach than it did to detach. And so I can go now, use that disk on another machine, and it'll pop up again as drive F on that other machine. So great. Let me get back to the slides here. Okay. Excellent. So the disk wrap sheet. For the OS, the maximum size is 127 gig. And again, we have the read-write cache. The main point for the OS disk is to just host the OS. We're hoping that all of your data that you end up wanting to really save and use sort of the highest throughput, the best latency, the best I/O per second, we want you to put on the data disks, right? The things that go directly through to storage will give you that better throughput. Data disk, we do allow up to 16 on extra large. It goes down by half based on size. So large will be 8, medium will be 4. Sort of see where I'm going with that. And they're maximum 1 terabyte each, right? So you can, and I think Mark showed this in his demo, you can have 16 disks, each 1 terabyte, that you can then span across them all to make technically a 16 terabyte disk. It allows you to really get some large stuff going. And then cache, again, I'm not going to spend too much time on it. For the performance workloads, definitely put it on the data disk and make sure there's no cache, right? Making sure that you can go right through to storage. Like I showed you with the storage auto load balancing, writing directly through to storage gives you the best I/O per second. So use the data disk for any of your performance checks, right? It's definitely where you'll get the best performance. Okay, storage pricing model. So just to quickly touch on this, because I talk a lot about storage, it's 1 million transactions for a dime. So here's an important point about Windows Azure that's a little bit tricky to sort of wrap your head around. The I/O, we were actually charging you per I/O. Now, the number is small enough that hopefully you don't notice, right? The times when you'll notice are when you're doing workloads that you actually know how much I/O you're using, right? Just Windows, you'll end up, the pricing becomes very, very low, right? We expect about 9 I/O per second running just sort of steady-state Windows. This ends up being about a dime for 3 days of running, which is a lot smaller than your core count. But it is something to keep in mind, right? And because it's a shared resource, we do charge for those transactions. Storage space, 100 gig for $12.50 a month. I'm sorry, I have dollars here. I should have converted this to euros. How silly of me. And then, of course, usage. You do pay for what you use, and this is an important point. So if you have that machine that I added, that 500 or 400 gig drive, because I didn't write anything to it, I'm actually paying 0 for it. Right? I will start paying for it when I start writing to it. This means you can create drives of pretty big, large size if you may use it someday, and then just pay for what you use. Now, there's one interesting caveat to this today during the preview, and something we want to fix in the future, is once you use it, we have no way of knowing you've stopped using it. Right? So we know when you've ever written to a page, but once you've written to it once, we will then continue to charge you. Right? So if you have a 1 terabyte drive, you fill it up, and then you reduce it and then delete everything from Windows' perspective. From storage's perspective, you haven't deleted everything because those drives are still marked as being written to. So it's something to keep in mind, and it is something that we do want to consider sort of a trim functionality to make that work better, but it is something to sort of be cautious of. And then one last thing with storage, like I said with leases, this is really for your own protection. When a VM created, we lock it, and we make sure that you're not going to go accidentally delete it. You can use an API that will work around that. It will actually bypass our lock. So it's not intended to block you from doing anything. It's really just to protect you. And to completely delete things, it's sort of a 2-step process. You first have to remove it from your account, and then you have to delete it in storage. And because this is somewhat confusing and important enough to talk about, let me actually show you real fast. Okay, So here in my storage account, let me go back to the portal and show you my disks. So here I have small data disk. This guy's sitting in my storage account. He's not connected to anything, but he is referenced in my account, and so I can see him there. So I go over here. This is the same guy. So I hit delete. Sure you want to delete this? Yes. And it comes back and says, uh-oh, we can't delete this. There's currently a lease. This is the protection of the system, right? This is actually a bug in Cloud Explorer. Even if I hit yes, it still won't delete it. So let me go back then to my account and say, all right, so let me go in here and actually dereference this guy. So small data disk, I don't want him listed here anymore. And so, again, this is not deleting the disk. This is dereferencing it from my account. And then I can go to my storage account and do with it what I will, copy it somewhere else, download it, or just delete it if I want to. And so let me go back over here to my storage account. Let me just refresh it real fast. And then I can go in here and say delete. And there you go. He's gone now. Right? And so now it gave me the ability, it unlocked it, and so now I could go ahead and delete it. Yeah, go ahead. It's great feedback. So the question was, the name in the portal is not very clear because it says delete disk. You'd expect it to be gone when you hit that. Yeah, I've filed a bug against that. So yeah, we'll fix that for sure. Really what's happening is we're dereferencing it, right? One of the two paths that we're going to go here to resolve that will either change the name in the portal to be clearer that it's actually just removing a reference, right? That it's actually sort of removing it from that list but not deleting it. But I think actually where we want to go is allow you to delete it directly from the portal. And this is something that we're working on with the portal guys and sort of the underlying API to make sure we can do that. It's good feedback. Yeah. Oh, I see. I see. You tried to delete it from Cloud Explorer or from some storage API? Oh, I see. Oh, from the portal. Oh, interesting. Okay. Yeah. Let's talk more afterwards. That may be an issue. Yeah, absolutely. That's great feedback. Yeah. Okay. So the final thing that I want to talk to you about is sort of, now that I've walked through sort of the basics, I've walked through a lot of sort of the gotchas, some of the ways things work, I want to just spend a couple minutes showing you how do I use this. So my favorite sort of example of how to get going, how to start using this, how to start playing with this is really a dev test experience. And so if you've got this VM up and running, you're happy with it, but then you want to shut it down for the night, whatever it may be, you want to shut it down for a couple months, you just delete that VM. Those VHDs still sit in your storage account. Right? So you're still sitting in the storage account, you've got that VM's VHD sitting there. Then the next day, the next month, whatever, you can come back up and you can create that from that disk. Right? So you go and you say, great, I'll go restart my VM and go create that from that same disk. Yeah, go ahead. So you actually need to delete the VM. When you're stopped, we actually keep you reserved on those cores to make start much faster. So the way we treat stop today is to be sort of as fast as possible to restart it. If you're going to do it for a long period of time, we recommend you delete the VM. Now, there's one important point to that actually I'll cover right here, which is deleting the VM means you actually lose reference to things like data disk, which is this purple line, and perhaps input endpoints, which is, port 80 is open, for example, on this virtual machine. So if you're using it and you've got an OS disk, you've got a couple data disks, you've got maybe an incoming port on port 80, we actually have a PowerShell capability that allows you to import-export this. Right? And so what we actually do is through PowerShell, we'll save it into an XML file as a part of this import command, export command. And then, of course, you can bring this back later with an import command and reconnect it. And it will reestablish all those connections based on those disks. So let me actually show you this. Here's sort of the example. You can find this, obviously, through the PowerShell examples. It's the only code that I kind of put in the deck. But let me actually show it to you here. Okay. So I've already created this XML. And so, let's say earlier this week, I created this jump box, and I exported it using the PowerShell capabilities. And so this is the XML. You don't actually need to read this. This is meant to be just a file that's sitting on your disk for you to import again. But just to kind of show you some of the obvious things, it's got a load balance endpoint on port 80, and it's got a couple disks that it's going to use. It's going to use the medium data disk. Let's see here. It's going to use the medium data disk, and it's also going to use this jump box VHD that I've got set aside. So here you can see, here's my medium data disk. And, of course, the jump box is right there as well. So these guys are ready to be used. Let's make sure that I'm not actually booting from these now. Great. OK. OK, cool. So from PowerShell now, you can see for import, all I'm listing is I'm picking the name that I want this service to show up as, which will also be the DNS name. Right? So I'll probably pick the same one that I had before, and, of course, reference that XML file that I just mentioned. Sorry, ask the question again. So you pick the cloud service that you want it to join to. So you can either you'll pick the same name, let's say, that you want to join that cloud service. Yep. Correct. The cloud service you don't pay for in the meantime. That's right. So now you can see this guy got started up. Let me go back over here. Go to my virtual machines, and he'll pop in here in a minute, and we'll be able to take a look at it. Okay. In the meantime, let me go back here and sort of finish up just a few points. So when you're deploying, and I don't go into too much detail on this, there will be a networking talk actually later that'll spend more time on it. But when you're actually deploying, and let's say you want 2 virtual machines or 3 or 4 to be able to sort of talk to each other, but interact, they're part of the same application, one way to do it is to actually group them. Right? And so one of the things that you saw as part of that portal was connect to another existing virtual machine. So when you deploy a single machine, like all the demos I've shown you so far, they're standalone virtual machines, they're sitting alone, and they have an external endpoint that they can talk to. If you want to connect a couple, you can actually go in and say, these 2 guys should connect and talk to each other. They then get deployed as part of the same cloud service. And what this means is you can do things like load balancing on them. You can do things like they can talk to each other directly using their backend IP, so their 10 dot address range. You can also use Azure supplied DNS to be able to talk to these guys using just the Azure DNS connectivity. And so with that, you're able to do some interesting things. And let me quickly connect here. Well, and so what does grouping get you? Well, it gets you load balancing, like I said. It gets you high availability. So you can actually create availability sets using this. And Vijay spends quite a bit more time on this in a later session. I think it's called Deep Dive of Windows Azure, where he'll talk about a few of these capabilities. It gives you that automated subnet connectivity, I quote subnet, intended to be sort of this connectivity on that 10 dot address range. And then it gives you Azure provided DNS. So when I say load balancing high availability, this means a couple things. High availability for availability sets means you can put 2 virtual machines, let's say 2 SQL servers, if you're mirroring them, right, or 2 SharePoint front ends, right, that you want to be able to balance traffic on. You can put them in the same availability set. What this means is that we will then make sure they're not on the same physical box, and we'll make sure that they're spanned across multiple racks. And so there's no single point of failure then for these virtual machines, which gives you this high availability. You can also do load balancing, which then will give you TCP or UDP load balancing across multiple VMs. And so you can imagine this being a SharePoint farm. Let's say we have some issue, that hardware goes down, some failure in a TOR, we lose a rack. It doesn't happen that often, but it does happen. With this a bit high availability and this load balancing, it means these other 2 instances, these other 2 instances then take that traffic up. And that middle one dies, he comes back up later, and we again recover from that later on. Excellent. So then the automated Azure provided DNS, this is just kind of a tip of the iceberg. Again, Ganesh will cover this later. If you're on test VM 1 and you want to talk and you don't want to set up your own DNS server, right? So you just set up 2 virtual machines, You want these guys just to talk to each other. Test VM1 can say, hey, who is test VM2? And our DNS server will reply back, oh, here's the IP address. And then you're able to connect. One of the important aspects of this, though, is that we do block out bad guys from being able to even find out the IP address. So the response, it won't even be responded to if you're not in the same cloud service. All right, let me actually quickly show what that looks like real fast. Sorry. Okay, so you see here in my cloud services, here I have a cloud service that I created before I came. And so in here I have two Windows Server 2012 images. I'm sorry, running machines, VM1 and VM2. And so I've connected to these guys. See here, here's VM1, and here's VM2 running. Okay? And so from Windows Server VM1, I'm sorry, this is from Windows Server 2012 VM2, I can go do interesting things like ping. So the other guy's name is, sorry, just trying to remember his name here. Windows 2012 VM1, thank you. And there you go, I have his 10.address range, he's responding. So then I can, of course, do lots of interesting things, but let me just start with this. And connect using remote desktop, using the 10.address range. Much faster because he's, of course, within the same data center. And there you go. I'm on this guy that I was adding the disks to. And I can manage him and manipulate him from this other VM using that 10.address range. Excellent. Okay. So the last things I wanted to talk about were really going back to those applications and just giving some best practices around those applications. For SQL Server, now that you've learned so much about the platform, few things. For your disk setup, make sure you're using data disks. As I mentioned before, you do not want to put your SQL Server database on either the OS disk or the D drive. The D drive will be lost. The OS disk will not be as fast as you want it to be. So put it on a data disk. For workload and sizing, the largest VM that we give you is a 14 gig, 8 core. We are looking at some improvements here to make this a little bit better for SQL-like workloads, but that is the maximum. High availability. You want to use database mirroring, and you want to use the availability set concept that I showed you. Right? You want to be able to span these guys, multiple instances, probably with a witness as well. We are looking at always on as well, but that isn't supported today. And then, of course, for disaster recovery, log shipping for SQL, if you want to do an application-based disaster recovery solution. You can also use our georeplication solution. The one key point with georeplication that I will mention that's worth noting, georeplication on multiple disks is not guaranteed to be transactional across those multiple disks. So if you end up creating a SQL Server database and you start spanning 3 data disks, do not rely on our georeplication system for your DR. It's very important because it will replicate at different rates, and then if you're spanning across them, that different rates will mean that data will be useless on georeplication. So our georeplication storage solution is really intended for single disks. Once you start spanning multiple disks, you could get yourself into trouble. Right? So in those cases, do rely on log shipping as your DR story. So for Active Directory, there's a couple of ways to deploy Active Directory that may be interesting. There was an entire dedicated session on Active Directory, so I'm not going to do it too much justice here. But the two obvious ways is, one, you can deploy using a cross-premise connectivity, which I didn't spend really any time on, and there's a whole session dedicated on this to be able to connect a virtual network and be able to span cross-premises. And so using that, you can have your Active Directory connect back on premises, right? And then you can use that for your deployment. You can also just deploy it standalone in the cloud, right? And so if you're using your Active Directory, let's say for machine auth, and this a great example of this is a SharePoint farm, right? A SharePoint farm that requires Active Directory to be a part of its solution, but you may not have user auth that's required. You can spin this all up locally within Active Directory in the cloud. That is supported. For this, of course, use the data disk as well. Do not copy the VHD. This is sort of a do not copy it and redeploy it in that same connection. This is sort of an Active Directory rule. If you're familiar with Active Directory, they're very sensitive to going back in time, as they call it, and the fact that it will poison the well, as they also call it. So you want to be very careful about the whole VHD mobility concept. With Active Directory, you want to be careful about how you move these things around. For this, of course, there's lots of different deployment types. Like I said, you can do local. You can just use your on-premise. You can have a read-only DC in the cloud and replicate back on premises, and you can even use ADFS. The one key thing that is interesting to point out specifically with a read-only DC, if you have an on-premise AD that you're trying to use for user auth, you may want to have a read-only DC in the cloud if you're comfortable with it, simply because if the network connection goes down, Active Directory is very good at handling that, right? It, I think, can go for 24 hours without having any replication. But if you're using an on-premise AD and don't have one replicated in the cloud, if your connection goes down, you've lost all of your Active Directory connectivity and your app goes down, right? So that's something really important to think about when you're sort of devising your strategy about how Active Directory is going to work. Active Directory is great at this remote office concept, so leverage it. And think of Windows Azure as a remote office, because it really is sort of what it is. Great. And then the last big one, obviously SharePoint, and you sort of lean on those same points for SQL and Active Directory to deploy SharePoint. So there's two big SharePoint deployments. One is, of course, using an on-premise Active Directory to get your user auth, right? And then you can, of course, connect through that front end using that user auth. There's also just the Fizz type deployment, where it's all enclosed in the cloud. You still need Active Directory for machine auth, but you don't have any users there, and you just have an unauthenticated access for your website. Right, and this also is something that is supported. And so for SharePoint, it ends up being sort of that same point that I mentioned. SQL Server 2008 R2 or 2012 if you're using SP1 of SharePoint. For backup, you can use the typical sort of SharePoint backup, SQL backup there. Active Directory setup, we do expect that local AD to be there. SharePoint does. It's very chatty with Active Directory. And so it is probably a good idea to have your read-only DC there in the cloud. And then, of course, high availability, you do want to put those multiple front ends, and you want them to be load balanced across an availability set as well. Okay. And then, of course, just one quick sort of last point. For virtual machine management, remote desktop, this is sort of the best way to go manage it. You want to be able to get in there and sort of use it. Windows Update, this will be on by default. This was sort of, this is an interesting one. We grappled with this for many weeks over what the right approach was. We decided we wanted it on by default, even though you probably don't manage using Windows Update. You manage using some other tool, or you manually do it. The reason why we wanted to turn it on by default is we felt it would be remiss of us to leave these things unpatched and you not know about it. Right? We'd rather have it get patched and you be surprised than not be patched and you not know for many, many months that your machines weren't being patched by us. So this patching is sort of your responsibility, but we turned it on by default just in case you didn't know it was your responsibility. And then management tooling, System Center Operation, you can use any tooling, right? Because once you have Active Directory connected and once you have a virtual network set up, you can use whatever tooling you want. I put System Center Operations Manager. We did test this. It does work. And so this is why I put this. But you can use whatever tooling you want. Again, it's that remote office concept, and you can use what you need there. Okay. A lot of content, short amount of time, a lot of demos. Are there any questions? I have about 3 minutes. So, yeah, go ahead. IPv6. Are we saying anything about IPv6, Ganesh? We're working on it. There you go. So here, we know it's important. I think the first thing we are prioritizing is actually incoming IPv6 versus internal IPv6, right? So making sure that the incoming IP address is IPv6 versus machine to machine. I'm not sure we have a near roadmap for that as well. Got it. Got it. So it's definitely in our roadmap. Is there a specific usage case that you have in mind for IPv6? Just wondering. Yeah. Yeah, we know we have to do it. Yeah. Any other questions? Yeah, go ahead. Yeah. Yeah, great question. Yeah, good question. So the load balancer does not do layer 7 application-based load balancing, which means it is not strictly sticky. The key thing with SharePoint, we worked with the SharePoint team on this a lot, actually, and we said, hey, do you require this? Do people run this way? And they said mostly not. They don't do a lot of their caching on the front end. Most of the calls come in and go back to SQL anyway. And so the applications that are really impacted by the lack of sticky session are the ones that have heavy front-end caching. Dynamic CRM actually is an example of that, right? So Dynamic CRM has heavy front-end caching, which means it doesn't work as well. SharePoint actually always goes back or frequently goes back to SQL Server to get its data, which means the front end is less of a cache and more of just a sort of a filtering part of the application. Does that clarify that? And it is sticky load balancing, something that we want to do as well. Absolutely. Yeah, go ahead. Any other file formats in VHD? Great question. So one of the things that we do have, there is an accelerator product that I can point you to that allows you to sort of convert to VHD. Actually, in the cloud, we only support VHD. It's one of the things that we do want to do is support sort of a conversion service as part of upload, which we haven't yet done. But yeah, the actual boot capabilities in the cloud itself are all VHD only. Are you thinking VHDX or are you thinking VMDK? Or you just wanted to know? Just wanted to know. Okay. Sorry, didn't mean to put you on the spot. Tell me why. Yeah, go ahead. We do not. Yeah, good question. Yeah. Anything else? Any other questions? Go ahead. There is a possibility to connect to VPN. When's your session, Ganesh? When's the VPN session? Tomorrow at 4:30 tomorrow is an entire 75 minutes about VPN and virtual networks, more than you ever wanted to know. Well, sorry, more than I want to know. Go ahead. Right, so when the VMs are deleted, all the core billing is suspended. You're still paying for the storage costs, right? So the storage is still there, the VHDs, until you delete them. Right, but when you delete the VM, the billing for the cores are gone. When you stop VMs, we continue to bill you for cores. Sorry, ask your question again. Can we block? Oh, I see. Can we ACL that public IP? We cannot yet. Yeah, that's one. You can only have one. Yeah. Cool. All right. My time's up. They're going to kick me out. Please do submit evaluations. It's how I get better or feel good about what I did. So either way, thank you.